Have you ever driven down a long stretch of road and wondered why almost all of them are black? Why are roads made of asphalt and not something else? And why does it seem like every country uses the exact same material? Well, the answer is actually a combination of many things. And once you understand them all, you'll realize that asphalt really is the perfect material for roads, even if it's not the strongest option out there. But it's a complicated story. It's a story about economics, about physics, about history, and about a material that has been used by humans for almost 3,000 years. So, let's start with the numbers. Of the approximately 2.3 million miles of paved roads in the United States, 94% of them are surfaced with asphalt. That's not a small majority. That's an overwhelming dominance. 4 states have 100% asphalt paved roads. 30 states have 97% or more asphalt paved roads. And all but 4 states have 90% or more asphalt paved roads. That's not a coincidence. That's the result of decades of engineering, economics, and practical experience. And it's not just the United States. More than 90% of Canadian roads are asphalt, and more than 96% of Mexico's roads use it. The figures for every continent in the world are similar. So what makes asphalt so special? First and foremost, asphalt is cheap, at least in the short term. Asphalt generally has a lower installation cost compared to concrete, which makes it appealing to agencies with strained budgets. And that's most of them. When you're building hundreds or thousands of miles of road, every dollar counts. Asphalt allows you to stretch your budget further and build more roads with the same amount of money. But it's not just the cost of the material itself. It's also the speed of installation. Asphalt can be placed and driven on within the same day. Imagine the chaos if a highway was closed for weeks while the concrete cured. With asphalt, you can pave a section in the morning and have cars driving on it by the afternoon. This is incredibly convenient for traffic that rarely stops moving. Concrete, on the other hand, takes much longer to construct. It has an extended cure time that can take many days, if not weeks, before it can be driven on. And that downtime is expensive. Closed roads cost money, create traffic jams, and frustrate everyone. But there's another reason asphalt dominates. It's the master of flexibility. Asphalt is a flexible pavement material. Unlike concrete, which is rigid and has no flex or give at all, asphalt tends to move and rebound without permanently shifting from its original position. This flexibility is actually a huge advantage. Think of it this way. When you drive over an asphalt road, the surface flexes slightly under the weight of your vehicle. The load is transmitted through the entire pavement structure, spreading out the weight over a larger area. This is why asphalt is often called flexible pavement. When you drive over concrete, there's no give. And over time, that rigidity can cause problems. The weight of traffic, the shifting of the ground underneath, and temperature changes can cause concrete to crack. Asphalt can handle the ground shifting underneath. It moves with the earth, flexing and bending without breaking. When asphalt does crack, water can still enter the cracks and get underneath, but the pavement is not very likely to move significantly from its original position, assuming it has proper drainage. But wait, there's another huge factor: recyclability. Asphalt is the most recycled material in the world. An estimated 95% of asphalt waste is reused in some capacity, most of which goes back into new asphalt mixtures. That's an incredible number. Nearly everything that gets torn up from old roads gets put back into new roads. Every year, nearly 100 million tons of recycled asphalt pavement is recycled back into new asphalt pavement in the United States. All the asphalt binder and aggregate are recycled back into the mix. Not only is asphalt highly recyclable, but it also has a long history of accommodating other industries' recycled materials. Ground tire rubber from old tires, plastics, roofing shingles, waste engine oil, and fibers. All of these can be incorporated into asphalt mixtures. And then there are the safety benefits. Asphalt is engineered to provide excellent traction to the driving public, and its black surface reduces glare and reflectivity common to concrete surfaces. When you drive on a sunny day, concrete can be blindingly bright. Asphalt is dark, absorbing light rather than reflecting it. What's more, compared with concrete, asphalt provides better traction, and its heat-absorbing blackness helps snow and ice to melt on it, and rainwater to evaporate from it more quickly. That means safer driving conditions in winter weather. Asphalt is also quieter to drive on than concrete. You may have noticed this when an asphalt highway gives way to a concrete overpass. The sound changes immediately. There's no thump, thump, thump as you drive on asphalt. It provides the highest level of smoothness compared to all other pavement types. So, what about the downsides? Asphalt is relatively soft and deteriorates more quickly than concrete. If you put something heavy enough right on top of it and let it sit there for an extended period of time, it could deform or rut. But even then, asphalt's maintenance and repair is easier and less costly than upkeep of concrete pavement. Fixing a pothole in asphalt is relatively straightforward. Fixing a crack in concrete is much more complicated and expensive. Concrete can have a lower life cycle cost over 30 to 40 years because it requires less frequent repairs. However, the initial cost is higher, and the installation takes much longer. So the choice between asphalt and concrete really depends on whether you prioritize short-term cost and speed or long-term durability. And let's not forget the history. Asphalt has been used by humans for thousands of years. The first recorded use of asphalt as a road building material was in Babylon around 625 BC, in the reign of King Nabopolassar. An inscription on a brick records the paving of Procession Street in Babylon with asphalt and burned brick. For thousands of years, humans have known the value of this material. The word asphalt itself is a bit confusing. What we call asphalt in the US is often called bitumen or tarmac in other countries. Technically, asphalt concrete consists of two primary components: bitumen, which is the binder, and mineral aggregates. Aggregates, which include crushed stone, gravel, and sand, typically constitute 70 to 85% of the mixture by weight. The bitumen coats the aggregate particles and provides cohesion, elasticity, and resistance to deformation. Finally, there's the science. Asphalt is being made better all the time. Modern asphalt is no longer just a waste byproduct of crude petroleum refining. It's a sophisticated engineered material. Researchers are constantly developing ways to improve it. Warm mix asphalt technologies lower production temperatures to the range of 100 to 140 degrees Celsius through the addition of chemical additives, wax, or water-based foaming agents. This reduces energy consumption and emissions and cools more quickly when compacted on the road surface, allowing for road surfaces to be laid faster and particularly aiding repairs. Inorganic nanomaterials can be added to asphalt to improve its anti-aging and anti-oxidation capacity. Modified asphalt exhibits enhanced stability at high temperatures. And reclaimed asphalt pavement is incorporated back into new mixtures at rates of 20 to 50% in many jurisdictions. The bottom line is that asphalt is the most practical material for roads because it's cheap, fast to install, flexible, safe to drive on, and highly recyclable. It's not the strongest material, but it doesn't need to be. It just needs to be good enough for the job. And for the vast majority of roads, it absolutely is. That's why 94% of American roads are paved with asphalt, and why it has been used for almost 3,000 years.